This is a lovely question. I'll classify this question as a GMAT 700 level DS question and number properties. What are the concepts that we need to know to solve this question? Euclid's division lemma, definitely, especially properties about what values the remainders can take. The second one is basically modular arithmetic, right? How do you work with modulo arithmetic? That's essentially what we're going to be looking at. When a positive integer x is divided by a divisor d, the remainder that we get is basically 24. What we need to compute is the value of the divisor based on the information given in the two statements. We know the 5 answer options, quickly run through them, and the question is what is d? We need to find the value for the divisor. If you're going to say finally as an answer, if you're able to find an answer, d is equal to, let's say, 28, d is equal to 42. The answer to the question is a number because it's a what is the value of the divisor question. For a value question, the answer is a number. The data is sufficient when we have a unique value. So we've got these things in place. I'm going to spend one more minute in looking at two properties, rules, things that we need to know to solve this question. The first one is essentially from Euclid's division lemma. It essentially says the remainder obtained when dividing a number by a divisor d is lesser than the divisor. Essentially what it means is the values that the remainder can take can range from a 0 all the way up to a number that's less than the divisor. The divisor is a 40, the remainder can take values from 0 to 39. The divisor is a 28, the remainder can take values from 0 to 27. That's essentially what it is saying. Let's go back to the question stem. What does the question stem tell us about what we know? It says that the remainder of this division is at 24. When x is divided by d, you get a remainder which is 24. The remainders can take values which are up to d minus 1, which means the least value that the divisor can take based on this information in the question stem is that the least value for d has to be greater than or equal to 25, because when x is divided by the divisor, we got a remainder of 24. The remainder will always be lesser than the divisor, which means the divisor cannot be at 24 or a number lesser than that. It has to be a number which is greater than 24. So it's at least at 25, it can be greater than 25. That's the first inference we are drawing. The second one, which is what we are going to be using to solve these statements, the remainder of the sum of two numbers is the same as the sum of the remainders. If you have two numbers a and b divided by a common divisor d, and I get remainders r1 and r2 respectively, then when a plus b is divided by d, the remainder will be r1 plus r2, subject to the fact that this r1 plus r2, that value should be lesser than the divisor. If it is more than the divisor, if r1 plus r2 is greater than or equal to the divisor, we will find the remainder by dividing this r1 by r2 by the divisor and find out what the remainder of that division is. Run through this once more. If you have two numbers a and b divided by a common divisor d, and we get remainders as r1 and r2. Then when the sum of these two numbers, that's what this property says, is divided by the same divisor, the remainder is going to be the sum of the remainders. Obviously, we need to keep this factor in mind. The remainder, whether you find it as sum or whatever process you find out, the remainder can never be equal to the divisor or greater than the divisor. So this r1 plus r2 ended up being equal to the divisor or greater than the divisor. What we'll do is, we'll take this r1 plus r2, divide it again by the divisor, compute the remainder of the division. That's going to be the final remainder. So this process is clear to us. We know what are the rules we are going to be applying, and we'll start looking at statement 1 to see whether that can give us a definitive answer. What do I know here? We know that d as a number is greater than or equal to 25. It cannot be lesser than 25. This is from the question stem because the remainder when x is divided by d is at 24, right? When 2x is divided by d, the remainder is 23. 2x is nothing but x plus x. X by d, the remainder is 24. Another x by d, the remainder is 24. Therefore, 2x by d is essentially x plus x. So the remainders should be added. So the remainder of this division 2x by d should be a 48 by the modulo arithmetic rule that we had. But what does this question say? The statement states that when 2x is divided by d, the remainder is not a 48, the remainder is 23. Why would it be that way? Because it would have happened that this value, this 2r that we have got, ended up being a number which is greater than the divisor. So what we would have done is, we would have taken this 2r, 48, divided it by the divisor, got some quotient along the way, and would have ended up with a remainder which is equal to 23. So therefore we can say 48 is equal to nd plus 23. So 25, taking this 23 to the left hand side, is equal to n into d. So 25 is some multiple of our divisor. Let's quickly check out what all possible values are there. ND, if it is equal to 25, values that N and D can take would be 1, 25, 5, 5, 25, 1. So the values that you get for the divisor are basically 1, 5 and 25. Now juxtapose this information. The divisor should be greater than or equal to 25, and these are the three possible values you got for the divisor. Obviously that rules out 5 and 1 as possible answers. That leaves us with only 25 as the answer. So what's the value of the divisor? The divisor, we have been able to find a unique value, and that is equal to 25. The divisor is 25. When x divides the divisor, can the remainder be at 24? Yes, possible. Can the remainder be a 48? No, because the divisor is 25. That R1 plus R2, when 2x is divided by it, could not have been a 48. That's why we would have divided that 48 again by the divisor to arrive at a remainder 23 to make this statement true. So did we get a unique answer with statement 1? Yes, statement 1 alone is sufficient. 1 alone is sufficient. Answer options will be A or D. Take a look at statement 2. It's fun to an interesting statement again. Again, go back to this. From this, we know that D is greater than or equal to 25. It should be at least at 25. It cannot be less than 25. When 3x is divided by D, the remainder is 22. Okay, we'll run through the same modular arithmetic. X by D is at 24. X by D is at 24. X by D is at 24. So sum of these three, essentially 3x is essentially x plus x plus x. So you're going to add the remainders. So 3x by D, the remainder should have been 72. The statement says the remainder is not 72, the remainder is at 22. Essentially because the 72, right, R1 plus R2 plus R3 that we have got, or 3R that we have got, is a value which is greater than the divisor. So what we have done is, we have taken this 72, divided by the divisor, got some quotient n, and got a remainder which is 22. We know D is greater than or equal to 25, keep that perspective in mind. So 72 is equal to n times D plus that remainder which is 22, or ND works out to 72 minus 22, which is equal to 50. So some multiple of a divisor is equal to 50. Let's see what all possible ways are there. ND is equal to a 50. What all values can N and D take? Could be a 1 into 50, 2 into 25, 3, 4, 5 are not divided, 5 is a divisor, 5 into 10, 6 will not divide 50, 7 will not divide, 8 will not divide, 9 will not divide, 10 we have already got. So these are all the factors. So essentially 10, 5, 25 to 51. These are all the possible values that the divisor can take. Now juxtapose that with this information that D should be greater than or equal to 25. Not greater than or equal to 25, not greater than or equal to 25, all these four are ruled out. So still we are left with two possibilities. The divisor could be a 25 or the divisor could be a 50. This information will hold good. So we got two values for the divisor, so statement 2 alone is not sufficient. I will just spend another half a minute in establishing that, right. So if we know that for 3x divided by the divisor, the remainder should be 3 times 24, which is a 72. If the divisor had been a 50, we would say, hey, 72, the value that we got is greater than 50. So divide the 72 by 50 and find out the remainder, that's a 22. Possible. If the divisor is a 50, can the original remainder be at 24? Yes, the remainder is a number lesser than the divisor, therefore that's possible. Both hold good for divisor being a 50. Let's look at 3x by D. 72 is the remainder. Let's say our divisor is a 25. In this case, you'll say the divisor is 25. You cannot have a remainder of 72. So divide the 72 again by a 50. 2 times 50, again by the divisor, which is 25 in this case, my bad. So 25 into 2 makes it a 50. The remainder is going to be equal to a 22. So that holds good. So the statement is holding good. When x is divided by 25, can the remainder be at 24? Certainly possible, because the remainder 24 is a number lesser than 25. So both values of divisors make the information given in the question stem and that given in statement 2 holding good. So we don't have a unique value for the remainder. Statement 2 alone is not sufficient. 1 is sufficient. Choice A is the correct answer to the question.